Okay guys, so let's plug CMK Computer in, and here we go. And yeah, we're coming to like the main loop. So here the keypad and these buttons are doing all of the controls, but here is a tiny little thing. So first of all, so by default, you see like this this sign tells us that we are currently in the address mode. And this is like inspired by the Key1 ROM in particular. So for instance, now if I just try to type some address, if the address is available, it would be displayed. Otherwise, it's just gonna be showing that it's not available. Nothing special so far. And the same way, if I go to the data mode, I can like change something as well, but that's actually drop back to the initial value that we had. However, if we press the select button, you see like the mode has changed to so-called command mode. So far we were within let's call it digit mode, but now it's the command mode. This star actually tells us about this. And here we have some applications. We can also switch now the memory and the data like this. But even more interestingly, we can switch from displaying the character here to display the assembly instructions. So it's kind of built in this assembler, which makes it possible to actually develop the program just directly within, like under this computer. And this is really important because you can just, for instance, like pick whatever instruction you want to consider, right, over in here, and then respectively to like, so once we got it, and also if we want, say, some character, it's not saying here in particular, but if we just like, we can also inspect the characters that has been encoded into the LCD itself. But for instance, so here we have 0D. No, it's not correct. This should be 08 like this. But if we just drop back here, for instance, and say 61 like this, we have the character A being displayed. So two kind of modes. Yeah, but let's drop back to here to 8, which stands for low program counter instruction. Yeah. So by default, I have Chrome Dino game being kind of preloaded into RAM, and that can be changed. But so far, I'm just going to be running this Chrome Dino game. But before that, probably another thing to consider is the debugger, kind of built in debugger. So this D button invokes the debugger, and whatever button to press to get away from there. I'll demonstrate you this in a little bit detail, like in a few moments. But you see that the program counter is now at 0000. So we can press C and we go to where the program counter points to. So it's 0 here. And here, if we press F, this is the F button. In this case, we just run the program whatever we have. So it tells us that runs at 0000, and I'm using 0 to control. And now I can play Chrome Dino here. Okay, here we go. Oh, I almost lost, but yeah, not that fast. Okay. Yeah, playing Chrome Dino is an epic. Yeah, but game over. Yeah, that's it. Anyways, so for instance, I want to play one more time. Well, by the way, I can have a look at the debugger. So now we have the current values. After we've dropped the execution, we have the values at A, B register, the program counter. Stack has dropped back, although we've been calling some functions. The 0 flag is currently equal to 1. Like, yeah. Well, probably doesn't gonna make sense putting 0 here, but anyways, just for the sake of layout, gonna make sense. So drop back, and let's drop back to a digit mode, and let's go with like address 0000. And here, if you want to play the game one more time, just go back to command mode and press F. And I just do exactly the same thing. By the way, I can press F and drop back from the program execution, which kind of makes sense as well. But for instance, if I want to, so what do we have at the debugger? Have a lot of things. And also, if you have a look, it has kind of uploaded, like initialized, it has initialized sort of, so just go back Nope. Oh, I shouldn't be doing this. I really shouldn't be. Okay, actually, yeah, it's fine. Yeah, low program counter, but yeah. So here you see like it. The idea behind this LCD display, the first 7 characters, like the values from ASCII 0 to ASCII 7, it does kind of use like user-defined graphics, which has been encoded within the program itself. So for instance, if I just try to go down, so here we have like the particular symbols, you see like here, that has been initialized for the sake of the program, just to make sure it works. So if I want to reset everything, I just can say 0 here, and then characters being reset, the register is being reset as well as the memory. So now all the memory like contains kind of zeros here. So let's try. So you've just seen how the like press and F to run the entire program works. So let's consider a single step in mode, which is also available. You can execute one instruction at a time by pressing the E button here. So for instance, at 0, I want, let's say, data. No, I want to go for, yes, LDI. So no operation, yeah, LDI load instant value to accumulator, and then go into the next one. And here, for instance, let's disable assembly here and put the value of, I also need to do like this, the value of 61. Okay. And here, I just remembered this by heart, so I just say it's 02, which is, yeah, I just need to, no, not LDA, by the way, I actually want tab, so transfer the value of A to B register, and then, for instance, saying, like, again, LDY, and the value of, let's make it like, value of 5, but this should be character. So far so good. So going back to this mode, go into 0, 0, 0, 0. Oh no. Okay, this should be 0, 5, I guess. Yes. So going back to 0, 0, 0, 0. So let's have a look what we have. So 0, 1, A, 0, 3. Yes, it just can't do both opcodes and characters every time, but yes, if we just go back like to assembly mode, so we have LDI, the value of 61, then we have transfer the value from A register to B register, and then loading the value of 5 to the A register. It just prints the assembly, this assembly, but doesn't make sense here because just too small. Anyways, so if we just go where the program counter is pointing to, so debug, now we have this value. So now we'll execute the first instruction. This should load the value of 61 to the register A. So I go like this. So running executing instruction at 0000, address has kind of shifted, and you see like we have this 61 being loaded to the A register. So far so good. So the next step is to put the value of A register to the B register here. So if I do another single step here. Okay, and let's have a look. So we just did it, and the next we'll load the value of 5 to the A register. So let's have a look how it works. And yes, we got the value of 5 being loaded into the register A, and the program counter respectively like changes there as well. So we didn't call any functions, so stack pointer is like remaining the same. Also, we didn't do compare commands, so the 0 flag has not been affected, and we didn't actually load the value of 0, hence this wasn't affected as well. So this is kind of how it works, and now we'll demonstrate another little thing, well, another couple of things. So first let's just reset this. First, we can use up to 1K of EEPROM, because Arduino Nano has this 1K of EEPROM. Actually, this particular guy, it can kind of write even more. I'm not quite sure why. It seems like it just, instead of writing to EEPROM, it writes to its internal flash where the sketch has been flashed into. But anyways, I'm just using 1K here. So here is an idea. So now we have the Chrome Dino game being being kind of available in the RAM. But let's just to make sure that we can reset this. So let's reset this. And now I guess this button 3, this should be yes, RAM to EEPROM. So we just put all the zeros into the EEPROM. And just to demonstrate you this, just to prove this, so I just turn off and turn on. And if I now go to, so now I have the Chrome Dino. Yeah, see, like I have the bytes. This is the Chrome Dino. We don't quite care about this much. So going back and now go into command mode and loading data from EEPROM. EEPROM to RAM, and now we have all the zeros because before this we've written all the zeros into the EEPROM. So far so good. Now for instance I said reset again. Now we have this Chrome Dino being available in the RAM. So what we can do now we can just, so it seems like there were zeros in the EEPROM so far. So if I just again like store RAM to EEPROM, now Chrome Dino has been stored into the EEPROM. All right, and if I now just turn this off, for instance, and then turn this on again, and select and reset the random access memory. But now, if I just load the data from EEPROM, I guess this is it, right? Yeah, EEPROM to RAM, then suddenly I already have the Chrome Dino being loaded from EEPROM to RAM. And respectively, well, obviously I can now kind of run this, and this should be working just like it previously did. And yeah, exactly, in particular. So the idea is that you can be developing the program, then you just ended up the development for today. For instance, you just can store your work to EEPROM, then next time you're turning on your computer, you're just fetching this back from EEPROM to RAM, and you can continue your work. Well, alternatively, there is another option which is a little bit more interesting, which is you can actually upload data from the serial port and also write the data to the serial port. Let's actually kickstart with writing data to serial port, because this is a little bit more simple thing to consider. So imagine, so let me just start my Arduino IDE here. So, okay, and like this. Okay, so I'm starting Arduino IDE. I should have done this earlier, really. And I will show you how, for instance, we've written some, we've created a program using the CMK Computer. And yeah, now I just open the serial monitor. Yeah. And we want to store our work to PC, so to share on internet, whatever. So in this case, there is the B button. So I need to go to command mode, and the B button does this thing, saves to serial, saving, and here on the screen you can already see like how it writes all of the bytes. So it would be running up to 1K, so 1024 bytes to the serial port. Yeah, so entire game is here, so it can be then stored and like also, the same format is used to upload the data, so that's another thing I want to demonstrate. We don't even need the Arduino IDE for this, because we're gonna be uploading like the bare bytes, and for that purpose I've made a specific program which is called upload bytes using serial port to upload. In my case, this is dev TTY USB 0. If you're using something else, feel free to change this. 9600 baud rate, and this definitions here are also kind of working here for my setup at least. Okay, so I just also I have an assembler, so I need to first I will create. So for instance, I have this Mario Walk, the program that I've written in this CMK assembly to create like user-defined graphics of Mario walking across the LCD screen. So if I just open terminal here, and if I say, I don't need sudo here, just Python 3 and assembler and Mario Walk ASM, here we go. And it has just created Mario Walk TXT, which is just the plain bytes. So up to how many bytes was it there? It was like 153 bytes. So far so good. So now if I say sudo, because I'm going to be writing to tty, like USB tty, and then again Python 3, and then upload py, and I'm using Mario walk.txt, and I hit enter. Yeah, make sure the sudo password is here. And yeah, now once I did this, you should have noticed that the CMK computer has just kind of reacted to this. Well, not quite sure if this works from the very first attempt, but well, it's not always, but generally. So now if I say A, and nope, I should go to command mode. Let's reset everything. Now I say A, so I'm loading from serial, waiting for incoming data, and I press enter. Yeah, it seems like it just uploaded, and just to make sure it works, let's say F, and yeah, let's first go to the very beginning and run send 00. Yeah, indeed, we have this Mario walking across the screen, which is exactly the program that we've just uploaded. So far so good. So by the time Mario is walking across the screen, well, let's try something more impressive, like hello world, for instance. So here I just can do like the hello world ASM exactly the same way, and let's reset Mario here. And now I want to upload, for instance, this way simpler program. So hello.txt. So yeah, CMK Computer reboots. When I'm invoking the serial now, I need to go to this command mode, pressing A to load from serial, and hit enter on my PC. It's loading, done. And I go to where the program counter is. Okay, and let's run. It should just be doing hello world. Well, not as impressive as walking Mario, but still. Yeah, and exactly the same thing can be done with Chrome Dino, but since I've already kind of demonstrated this, it didn't quite make sense. Okay, so this is in regards to demonstrating how it works on the real hardware, but also I have it working in the emulator, so let's have a look at that as well. Okay guys, so yeah, here is the emulated version of the CMK Computer version 2, and this in particular is tinkercad.com, which is the Arduino emulator and the circuit emulator, and it emulates Arduino at a very kind of circuit level, which is really cool. So here I have slightly different hardware as opposed to the real one. For instance, the layout of keys is just being turned counterclockwise. And I have manually added these buttons to mimic kind of these buttons I have here on the LCD display. And again, a keypad is just like turned, but that doesn't really matter that much really. And the entire source code that is allowing this kind of thing to run, let's actually start the simulation to actually give you an idea that it kind of works exactly the same way as the real hardware I've just demonstrated. So here we go. All right, so just a few words on the source code. So first, I don't define CMK hardware here in the emulated version because of the orientation of the keypad. And the rest then is quite similar. Maybe only the get character routine is, let me just quickly find the, yeah, here is the get character routine. So here in the emulated version I have the delay of 100 milliseconds, while on the real hardware it's 300 milliseconds, just to make sure that I'm unbouncing keys properly. And on the real hardware 300 milliseconds is really good enough, because this emulator is a little bit laggy and it works slightly bit not that as fast as the real hardware, maybe just a little bit slower. But the rest of things are exactly the same. So if I say press select, and so hash stands for F, star stands for E buttons. That's the way why I've been naming the buttons this exact way. So if I just now go like F to run the program, and I have exactly the same Chrome Dino here, just probably running a little bit slower, but still playable. So I can still play Chrome Dino. And yeah, actually I've been developing the entire updated version for the routine, like well, I'm not sure, maybe because of video recording software it just feels a little bit too laggy. Well, anyways, doesn't really matter that much. Yeah, probably, I'm not quite sure. Yeah, just for some reason just goes too slow. But anyways, the idea that it's exactly the same version as the one you've just seen on the real hardware, and you can do almost everything you can do on the real hardware. So here, for instance, if we have a look at the serial monitor, and if I say B, then I'm saving bytes to the serial monitor, and well, it takes quite a bit of time, and would eventually, whatever program you've written here in the emulator would just send in here. The problem is that you can't really do the opposite, so you can't really load via the serial port here, the emulated one, because it only supports sending the ASCII characters and not the raw bytes. So that's an issue. So, but there is a workaround with this. So what can be done, if you just have a look at the source code, then up here you have this program, whatever program you want to preload into RAM. You need to specify the length of the program and then the bytes themselves. And again, like these bytes can be taken from the text file is generated by the assembler.py, and it also tells you like how many bytes you have there. So you can literally change the prog length for the proper program you've written and assembled on the PC, and then you could just drop the bytes here, and then you can run, and you would be having this preloaded thing. If you want to disable this for some reason, that's also kind of possible. So you can just command out, like you can command these two lines of code, and no program would be preloaded on start. And yeah, it's just very laggy. You see, like it still tries to export, because it exports, yeah, now finally it's done. It exports all the 1K of bytes, so like 1024 bytes. It's being sent to this emulated serial port. And yeah, the rest of things is exactly the same. You can go to where the program counter is pointing here now. So for instance, you can go to address 0000. Yes, you can still change this mode to have these characters being uploaded. And for instance, if you just reset this, it just resets exactly the same how it resets on the real hardware. You have exactly the same debugger. So literally, the look and feel of this emulated version is like almost 100% the same as the real hardware